Chapter 8 ended with a pointed observation. The mechanics of a governance system can be taught, but the capacity to act honestly under pressure must be practiced. Culture, in the end, is what determines whether the formal system and the living system stay connected or drift apart without anyone noticing. That drift is exactly what Chapter 9 is designed to address. Not through more frameworks or heavier oversight, but through a different use of a tool most organizations already believe they are using well: artificial intelligence. The chapter's argument is specific. AI, applied within the DVMS structure, can map the living system in ways that human review alone never could, surfacing the gap between what the paper says and what the operation actually does, before that gap becomes a crisis. The question this chapter asks is not whether to use AI. Most organizations already do. The question is whether they are using it to decorate the paper system or to reveal the real one. The difference between those two applications is the difference between faster reporting and genuine assurance. Every major technology shift brings a version of the same temptation: to apply the new capability to the work you already understand, in the ways you already work. AI in governance is no different. Organizations reach for it to summarize policies, classify controls, and generate compliance reports faster. That is a real productivity gain. It is not assurance. The chapter opens with a distinction that needs to sit with the audience for a moment. AI changes the speed of assurance, not the mandate. The mandate is unchanged. Close the loop between what the organization promises and what it actually delivers. Speed without that closure just produces more confident noise. Within DVMS, AI earns its place as a system mapper and evidence assistant. Its job is to connect the signals that no human review team has the bandwidth to correlate: incidents against waivers, language patterns against boundary behavior, formal metrics against the informal signals that accumulate between reporting cycles. The goal is not a better dashboard. It is a clearer view of where the paper system and operational reality have quietly stopped matching. The risk with AI in any governance context is that it makes the paper system more convincing without making the living system more resilient. Applied without discipline, AI generates what this chapter calls sophisticated noise: artificial confidence assembled from disconnected logs, alerts, and artifacts that individually mean something, but together prove nothing about whether the organization can keep its operational promises. The alternative is equally clear. Applied within a structured framework, AI becomes something genuinely useful: a system mapper that holds the shape of what the organization said it would do, and an evidence assistant that surfaces where the actual behavior departs from that shape. The difference is not the technology. It is the question the technology is being asked to answer. That question, in DVMS terms, is always the same: where does the living system behave differently from what the paper world describes? And where do patterns of incidents, waivers, and language indicate that a capability is weaker than it appears? Every legitimate AI application in this chapter flows from those two questions. Everything else is decoration. Adding machine learning to a governance program without a clear purpose produces exactly what you would expect: more categories of data faster. The categories feel informative. They rarely improve decisions. Within DVMS, AI investment earns its place by answering two bounded questions, and only those two. The first is the reality gap. Where does the living system behave differently from what the paper world describes? The second is the failing loop. Where do patterns of incidents, waivers, and language indicate that a capability is weaker than it appears? Together, these questions define what AI is actually for in this context. They are not performance questions about whether teams are meeting targets. They are system questions about whether the organization's understanding of itself is accurate. Any AI application that cannot be traced back to one of those two questions is consuming resources to improve the paper system. It may produce impressive outputs. It will not improve what happens at Meridian's settlement boundary on a high-volume day, when a counterparty system slows and the documented failover path is bypassed by someone who has learned a faster workaround. Most enterprise AI tools are honest about what they do. They classify controls. They summarize policy coverage. They ask whether the framework is aligned and compliant. These are legitimate questions, and the outputs, heat maps of formal requirements, compliance scores by domain, are useful for audit preparation. What they cannot do is tell you whether the system actually works under pressure. The DVMS approach asks a different set of questions entirely. Instead of classifying controls, it observes behavior under pressure, hurry, and fatigue. Instead of asking whether the framework is compliant, it asks whether the stated causes of recurring exceptions are actually resolving those exceptions, or whether the same problems keep returning under different labels. And instead of producing flat heat maps of formal requirements, it produces topographical maps of mismatches and weak signals, the contours of where the living system diverges from what the paper claims. The distinction matters most when something goes wrong. A flat heat map of compliance tells you what the organization said it had in place. A topographical map of actual behavior tells you where the gap was, how long it had been accumulating, and which signals were visible before anyone chose to act on them. The mechanism that makes this possible is what the chapter calls the interpretive scaffold. It is not a new data platform or a replacement for existing tools. It is a structured way of filtering the artifacts that organizations already generate, incidents, waivers, questionnaires, logs, through the lens of the DVMS capabilities and boundaries, so that what comes out the other side is targeted rather than comprehensive. The key move is in the middle layer. Rather than blindly classifying artifacts into generic risk categories, the scaffold maps them against specific minimum viable capabilities at specific boundaries. An incident is not just an incident, it is an incident at a particular boundary, against a particular outcome, during a particular operating condition. That context is what transforms raw data into interpretable signal. Without it, you are sorting shapes into buckets. With it, you are building a picture of which parts of the living system are holding and which are quietly drifting. What comes out the other end is not a compliance score. It is a set of specific contradictions between what the organization formally claims and what its operational behavior actually shows. That is the kind of evidence that changes governance conversations, not because it is alarming, but because it is precise. Organizations close incidents. They rarely close the loops that incidents reveal. A ticket gets resolved, a root cause gets documented, a corrective action gets logged, and 3 months later, a different incident with a different stated cause produces the same operational failure at the same boundary. The pattern is visible in the data. It almost never surfaces in the review. This is what the first AI evidence stream is designed to expose. Incident records are not just histories of what broke. Analyzed across time and boundary, they reveal whether the system is actually learning, whether the fixes being applied are addressing the underlying condition, or whether the same structural weakness is being rediscovered repeatedly under rotating labels. When short-term fixes consistently fail to trigger architectural updates in the design capability, that failure is measurable. When the same boundary keeps generating incidents regardless of how the root cause is described each time, that recurrence is a signal the organization is not closing the loop. The gap between incident resolution and actual system learning is one of the most consequential blind spots in governance. AI does not close that gap. It makes the gap impossible to ignore. Every organization has gaps it has quietly decided to live with. Some of those decisions were made deliberately, with risk accepted and documented. Others were never made at all. They accumulated through a pattern of exceptions that were each individually justified, each individually approved, and together represent a structural vulnerability that no one has ever formally acknowledged. Waivers and exceptions are the evidence. Individually, they are routine governance transactions. In aggregate, they are a map of where the organization's actual operating standards have drifted from its documented ones. The AI stream that works on this data is doing something that no periodic review can accomplish. It is reading across all of those individual decisions simultaneously, surfacing which boundaries generate the highest ongoing exception volume, and identifying which rationales appear again and again in ways that suggest the formal governance response is not actually resolving the underlying condition. What that analysis produces is not a list of rule violations. It is a picture of where the organization has quietly accepted a gap it has never explicitly owned. Making that picture visible is the first step toward a governance conversation that is honest about what the organization actually does, rather than what it documents. By the time an incident is logged or a waiver is filed, the signal is already lagging the reality. The earliest evidence that something is drifting at a boundary typically appears much sooner, in the language that people use when they are working around a problem they do not yet have words for. Tickets written in a hurry contain different language than tickets written with time to think. Retrospectives dominated by blame language tell a different story than ones oriented toward inquiry. When workaround and bypass appear repeatedly in the informal chatter surrounding a specific boundary, something is concentrating there: friction, fragility, or a gap between the documented process and the one people have learned actually works. That language is a leading indicator, arriving weeks or months before the formal record catches up. Detecting those patterns at scale requires AI. No review team reads across thousands of tickets with the consistency needed to spot the signal. But the signal is present, and organizations that surface it early gain something genuinely valuable: the chance to address a structural weakness before it produces the incident that finally makes it undeniable. The assurance loop does not just need data. It needs early data read honestly. A formal metric holding steady, while the underlying reality deteriorates, is one of the most dangerous conditions in any governance system. The metric provides reassurance. The reassurance reduces scrutiny. The reduced scrutiny allows the deterioration to continue. By the time the metric finally moves, the gap between what it was measuring and what it was supposed to guarantee has already become structural. The fourth evidence stream targets this exact condition, which the chapter calls the snapping correlation. When a formal outcome metric holds steady while incident frequency and weak signals are climbing, the most likely explanation is not that the metric is resilient. It is that the metric has become decoupled from the outcome it was designed to track, that the measurement point is being bypassed, or that the behavior generating the metric has been optimized independently of the behavior the metric was meant to reflect. AI can detect this divergence before the snap. By correlating formal metric behavior against the informal signal stream simultaneously, it can flag when a metric is being managed rather than observed, and give governance the chance to ask the uncomfortable question before the answer becomes obvious from the failure. No single evidence stream is sufficient on its own. Incidents tell you what broke. Exceptions tell you what was quietly accepted. Language tells you what was felt before it was documented. Formal metrics tell you what was officially measured. Any one of those streams, read in isolation, can be explained away. Read together, they produce something that is much harder to dismiss. The synthesis is a cross-sectional core sample of the living system. 4 layers of evidence, each capturing a different register of organizational behavior, each connected to the same underlying question. Is the system actually working, or is it performing the appearance of working? When all 4 layers tell a consistent story, that convergence is strong evidence of genuine resilience. When they diverge, when the formal metrics are clean while the exception volume is climbing and the language is full of workarounds, the divergence itself is the finding. This is the diagnostic capability that no traditional dashboard can provide. Dashboards aggregate within a single evidence type. The multi-layered view correlates across types, at the boundaries where the organization has declared its commitments, against the outcomes it has promised to keep. That is what makes it governance rather than reporting. There is a version of AI-assisted governance that sounds compelling, but is structurally dangerous. One where AI not only surfaces the patterns but draws the conclusions, assigns the accountability, and recommends the posture. That version solves the bandwidth problem while creating a much larger one. It diffuses the human accountability that is the only reliable anchor of any assurance system. The boundary is precise and non-negotiable. AI functions as a system mapper and evidence assistant. It can analyze diverse evidence structures simultaneously, surface behavioral patterns that no human review team would catch, flag when a QOQM branch has drifted from reality, and accelerate the feedback loop that connects observation to action. What it cannot do is take ownership of governance outcomes, define the organization's risk appetite, replace the leaders whose job it is to face hard evidence, or issue verdicts without transparent reasoning that a human can interrogate and override. The reason the boundary matters is not philosophical. It is practical. When AI absorbs the decision rather than informing it, accountability diffuses. When accountability diffuses, the assurance loop loses its human anchor, and a loop without a human anchor is not a governance system. It is an automated paper system with better graphics. Every measurement system creates an incentive to optimize for the measure rather than the underlying condition. Goodhart's law, the observation that a measure ceases to be a good measure once it becomes a target, applies to AI governance outputs with particular force, because AI scores can be gamed in ways that are much harder to detect than traditional metric manipulation. When teams learn that AI is scoring their language and artifacts, the rational response is to write differently, not to behave differently. Incident retrospectives start sounding more like the retrospectives the model rewards. Waiver rationales are worded to avoid the patterns the model flags. The formal record improves. The living system degrades unnoticed because the measurement instrument has been trained to find what the organization has learned to show it. The mitigation is structural. AI outputs must function strictly as conversation starters in governance reviews, never as inputs to compensation, discipline, or performance evaluation. The moment an AI score carries formal consequences, teams will optimize for the score. Keeping it in the domain of evidence and inquiry, a prompt for a human conversation rather than a replacement for one, is what preserves the honest signal that makes the whole system worth running. Meridian experiences a high-volume stress event. A counterparty system slows, creating pressure at the settlement boundary. The documented failover path exists. It is not taken. Instead, an informal manual override is applied, faster, familiar to the team, unrecorded. Workaround language spikes in the operational chatter. The formal QOQM metric for time to failover reads green, 0 degradation, because the measurement point was bypassed entirely. This is the snapping correlation made concrete. The metric is clean because the process it was measuring did not happen. The living system solved the problem its own way, and the formal system registered a success it had no part in producing. From a governance perspective, this is not a good outcome wearing a green label. It is an invisible gap. The organization does not actually know whether its documented failover capability works, because the last time it was needed, someone went around it. What makes this findable is the combination of evidence streams working together. The language spike in operational communications, the absence of a formal incident record despite a stress event, and the flat metric despite known boundary pressure. No single stream reveals the problem. Together, they make it unmistakable. Observation without response is not assurance. What the AI surfaces at Meridian's settlement boundary has to travel through human judgment and capability response before it becomes governance. The three-part cycle on this slide shows how. Govern adjusts the outcome statement. The QOQM tree currently describes a failover path that the team has stopped using. That is not a documentation problem, it is a governance problem. The declared outcome no longer reflects operational reality, which means the metric measuring it is tracking the wrong thing. Updating the outcome statement forces an honest reckoning with what the organization is actually prepared to do under stress, rather than what it once designed to do. Design then updates the failover runbook to specifically address the counterparty slow response scenario that the team encountered, closing the gap between the documented procedure and the one that actually gets used. Finally, Assure resamples the boundary using the revised measurement points, verifying that the living system improved and not just the metric. That last step is the one that fails most often. Organizations update the documentation and move on, assuming the behavior will follow. The assurance verification is what distinguishes a governance cycle from a paperwork cycle. AI provides the observation. Human accountability closes the loop. Chapter 9 closes with a boundary that is worth stating plainly, because the pressure to cross it will be constant. AI accelerates the work without displacing the accountability. Those two functions, acceleration and accountability, belong to different actors, and keeping them separate is what makes the system trustworthy. On the side of what AI can do, analyze diverse evidence structures simultaneously, surface invisible behavioral patterns and weak signals, suggest when a QOQM branch has drifted from reality, and accelerate the assurance feedback loop. These are genuine capabilities that change the speed and reach of governance in ways that were not previously possible. They deserve to be used. On the side of what AI cannot do, take ownership of final governance outcomes, define organizational risk appetite or posture, replace leaders willing to face hard evidence, or provide verdicts without transparent reasoning. These are not limitations to be engineered around. They are the conditions under which governance remains accountable to the humans it is meant to protect. An organization that understands this distinction is ready to use AI as what it actually is: a powerful instrument in the hands of people who have decided what they are trying to govern and why it matters.